Hey, it's Alex Williams of the New Stack. Welcome to the New Stack Makers, a podcast where we talk about application development, deployment, and management at scale. Pivotal offers the platform, tools, and methodology to help you deliver exceptional user experiences. Pivotal Platform helps you ship and run all types of apps in a secure and highly available way anywhere you want. Pivotal partners with you to change how you build software. Learn more about Pivotal at pivotal.io. Hey, it's Spring One time, the Spring One platform time of year, isn't it?
It is.
Yes, and I'm here.
This event.
It's a great event. I'm here with Cornelia Davis, Vice President of Technology at Pivotal, and we are at Spring One platform in Austin, Texas. And Cornelia, you were on stage for today's keynotes and yesterday's keynotes, but I want to start with a question because I saw your T-shirt and I loved it on the book you've written about cloud native patterns. But
Yep.
I love to ask people how they got their start in technology. What were some of those, and how you got your start in technology, and what were some of those patterns that you were experiencing when you were first getting started? Where were you? How old were you?
Yeah. So I got incredibly lucky. So I've been doing this a while. So I was in high school back in the 80s. And so in 1981, when I was a junior going into my junior year in high school, I signed up for this computer programming class. This is in 1981.
Mm-hmm.
A lot of high schools today still don't even have that class. And I revolted. I was like, there is no way I'm doing this computing thing, this programming thing. I'm too cool for this. And so I resisted and didn't even go to class for the first couple of days. Long story short, I ended up showing up, still full of attitude. Teacher had 4-line program up on the board and said, who wants to try? And now curiosity is getting the better of me. So I walked over to the TRS-80s that were against the wall, and I typed in this 4-line program. And I typed the word RUN, which is how we ran programs back then on PCs, and it started counting on the screen, and that was it. That was literally it. I was like, oh my, that is super cool. And so that was hugely a defining moment. But when you use the word patterns, it brings up a thought around another kind of defining set of experiences that I had. I ended up going to university in the greater Los Angeles area because I'm from Southern California. Very pragmatic school, oriented toward getting students ready for industry. So in that, I learned a whole bunch of programming languages. Languages like C and Fortran and yes, COBOL and yes, Pascal, all imperative languages. I went out into the workforce, learned a few others. I started my career in aerospace, so I added Ada to the list. We did a lot with Ada. And then I decided to go back to school and pursue a PhD. I never finished it, but I went back to school, and I went to Indiana University, which is a very research-oriented school. And I ended up studying theory of computing and programming languages. And that combination of huge pragmatics in the first university and then really deep foundations of computing, mathematical foundations of computing, has served me extraordinarily well. And so I think in part my tendency to want to get back to first principles comes from that combination of experiences.
So going forward then to today, from those early days in high school and then studying both in Los Angeles and at Indiana University, you now are on stage and you're talking about patterns and we're talking about programming languages, and you were talking about Spring as a platform.
Yep.
What is your take on Java today? And some would say that Java is old school or whatever how you describe it, but programming languages all go through these different stages, don't they?
Yep.
Where would you see Java right now?
So it's extraordinary. Java is still growing. It's unbelievable. It's been 10 or more years and it's still growing. And I actually believe it's because of really the Spring framework. I think if Java had existed and had just continued in the way that it had really started getting into the enterprise, which is through the J2EE stacks and those types of things, it wouldn't have been the same. The reason that I think that the Spring framework makes such a big difference is that it is just that. It's a framework, it's open source, and so we started seeing lots and lots of innovation around the edges. And what's so cool about that is we're seeing that same pattern now play out in the Kubernetes space. Strong core, but it's not all about the core, it's all of the things that are going around the edges. So we've got all these different Spring projects. Yes, Spring Boot is the latest of the core of Spring, but then you've got all of these other patterns that are getting implemented in Java. Things like retries and React and all of these patterns that are really relevant that are getting added as extensions to the core framework.
And so in that, then we see the popularity of Spring, which is really unquestioned. How is that playing then into concepts that we're hearing a lot about today? You talked today about, and you had this one slide of like 1972 and 2019, and it was like, it was like a brook, right? And the water flows through the brook, right? Water's never static, right? But
that's right.
We've been trying very hard to move from like making things static, but keeping them progressing, and now we're moving much more into this much more flowing types of architectures. How does Java and Spring Platform come together in that context with Kubernetes?
Yeah. So, I mean, the first thing that I would say is that I strongly believe that the reason that we're moving in such a significant way in this direction is because our systems are just highly distributed now, way more than they were in the past. And that's where certainly Kubernetes has played a big role, having containers and those types of things, but actually containers also came out of a need for this high distribution. When I was in university, as I said 30 years ago, there was a distributed systems class. Not that many people signed up for it. It was very, very niche. But today, it's extraordinarily distributed. And by extraordinary, I mean not just, we've had distributed systems for a couple of decades, but it was still relatively tractable. We had the database tier, we had the services tier, and we had the front end. And we might have had a little bit of scale in and out on those, but it was still closer to static than it was highly distributed and constantly changing. And so those are the dynamics I think that have really changed where we're going. Now, the fact that the Java in the Spring framework has been able to keep pace with that, because with a disruption like that, you would think that possibly the languages would actually change as a part of that transformation. And sure, we see other languages that are coming along. And in fact, my favorite topic on that is around functional programming. And there are functional programming languages, some of which are built as extensions of the core JVM and Java. So it goes back to that concept of Java being the core, but being open to extensibility. And so I think Java's been really good at that. Scala is layered on top of Java, a functional programming language. But then some of these patterns that are really important, like service discovery, is something that, of course, it comes through even the connectivity with Netflix and the Netflix suite. But Netflix built that whole suite around highly distributed, constantly changing apps based on Java because it had a great core and great extensibility model.
In that respect, we're hearing at this conference about languages like Kotlin.
Yep.
What is Kotlin and what makes it so interesting for people?
Yeah, so Kotlin, Scala is another example, is Kotlin, I believe that the popularity of Kotlin is again because it is a functional programming language first. You can program imperatively, and in fact the functional programming language I programmed in while I was at Indiana University is Scheme, which is a dialect of Lisp. You can program imperatively with that, but it's kind of crazy. It's actually painful to do so. It can be done, but it's painful. It's much more natural that language is naturally designed for functional thinking. And Kotlin is the same way. You can program imperatively, but it actually encourages you to, I was just chatting with somebody this afternoon about Kotlin, and they said it's just more expressive rather than prescriptive. And so what is so cool about these functional languages where you're expressing your intent is you are somewhat ceding some of that control to an entity that's a whole lot better at managing distributed systems of tens of thousands or hundreds of thousands of nodes than human beings possibly can be.
I'd like to ask another question about when you're growing up and learning about technology and how your experience is, for instance, in programming and the first time you program, to put your program on a server, for example, and how now you think about continuous integration, continuous delivery today.
Yep. As I mentioned, I started my career in aerospace. So we certainly 30 years ago, we're not doing releases every day. Now, my husband stayed in aerospace, and they still, when I talk to him about this notion of releasing 100 times in a day, he's like, his head blows up. It's so counterintuitive to that. And in fact, I started with embedded systems. So I wasn't even deploying to a server. It was even harder than that because what we were oftentimes doing is actually putting this almost as firmware onto the hardware that was going to be flown in a missile, for example. So that was a very long and static process. And in fact, I don't even really, that was just part of the workflow, was that I'm not even sure in the beginning that I did that deployment. I was in algorithm development. It was a completely different set of individuals who took the algorithms that I designed and said, okay, now we're going to make this fit across the 3 static processors that we have in there. I do remember having the diagrams on the board where we actually timed out, because we had 3 processors on this missile, we timed out exactly how long it was going to take to do a particular calculation so that we could have lock points across these different servers. So it was a very, very static process. So, and really what that was, when I'm even telling that story, is that the different quote unquote threads, and it was really completely different processors, we did all of that tight coupling very early in the design. So if it took longer, for example, to calculate one portion of the calculations that we needed to do, and we missed our window for lock, the whole thing would stop working, because it was so tightly coupled so early in the development process. This was probably 5 years before we put the thing on a missile. And now what's happening is all of these systems, Kubernetes, and the way that we build the applications that are deployed to that, these cloud native applications, it's all about autonomy. It's about binding things together as late as possible. And in fact, as late as possible is usually during runtime.
Yeah, and that actually does happen. And there's a lot of discussion about that now, isn't
Yeah.
there? And so now when you think about continuous delivery, and that's been a discussion we've heard a lot about here, and then you tie it to culture and empowerment, how do you relate that to when you were first getting started? Was there that sense of empowerment, or was it more of an individual sense of empowerment that I can do this?
So there was absolutely not that sense of empowerment. But you know what? I wouldn't even say that I felt disempowered, because it was just, that's the way it works. And when I was at Cal State Northridge, doing my undergraduate, I took courses in software engineering where we were taught the waterfall methodology. I talk to my customers about this all the time, that the fact that you're doing waterfall is not a bad thing. That was the best practice. So I didn't feel disempowered. It was just, that was the state of the art. That's what we did to actually make systems and make our development processes work.
But it was much more of a solitary experience, wasn't it? I mean, I have heard people say that in today's world, how you work with teams, how you work with workflows across the team requires more collaboration.
Oh, no question.
And I think that was part of the questions I had in my mind, was when you're thinking about empowerment then, it was a more kind of an individual type of.
Yep. Yeah, no, I think that's a good point. And we did a lot of throwing things over the wall. And so we were actually very, very isolated from one another. And some of those barriers break down. Now, I don't want to give people the impression, though, that as we move into this new world, everybody is doing every job. There's still a partitioning, and I just recently had the great pleasure of working with a number of individuals to publish a white paper that was published by IT Revolution. This is Gene Kim's organization. It was a white paper, and it was effectively, I don't remember what we landed on for the exact title, but the title was something along the lines of debunking the myth of the full stack engineer. There's this notion, this naive notion that, okay, well, actually DevOps is all about having the full stack engineer who can do chips up to CSS. They're actually really good at doing deployments. They're really good at doing monitoring. They're really great programmers. They know how to tune their database, et cetera, et cetera. And that's kind of the naive way of looking at breaking down these silos. And what we talked about in there was really two themes. We talked about the fact that it's really full stack teams, and that's to your point, is now we have teams that are working collectively instead of throwing over the walls. So there's this notion of full stack teams, but even there, what is the stack that the team is responsible for?
Right.
And here at Pivotal, of course, we create a platform. And the partitioning of that has worked extremely well for our customers is that there's a platform team that's responsible for providing a platform. And then there's the team that's leveraging that platform to generate digital offerings for their customers on top of that. And that'll include people who are doing everything from making sure that quality is handled from the very beginning in your software so that we don't throw things over the wall to QA. It includes tuning the databases, message queues, and those types of things. But then the platform team has their product that they're responsible for.
In that, you talked about some of the core principles that Pivotal upholds. Can you talk about those core principles that you discussed today in your keynote?
Yeah, absolutely. And so what we were doing in that talk was we were actually speaking to this shift that we're having towards these cloud native applications. And there's quite a number of patterns out there, and the patterns that everybody is probably familiar with. Everybody's heard of circuit breakers. Everybody's heard of service discovery. Everybody's heard of retries and those types of things. And those patterns aren't actually difficult. I mean, a retry at its core is a very, very simple thing. The analogy I will always use is when you and I are browsing the web and I click on a hyperlink and it spins for a few seconds and it doesn't render the page, do we give up and go home? No, we hit refresh. We hit stop or we click on the link again and oh, there it goes. That's you and I doing a retry. Well, we do that in software as well. The principle is very simple, but if you don't understand the context in which that retry is happening and what some of the cascading effects can be, then you can end up in a world of hurt. So if you've got a whole bunch of systems that are doing retries in a naive way during a 5-second network blip, when that network comes back, you can have a full meltdown of your system because you've now DDoSed yourself. You have a retry storm. And so what Mark and I did this morning was we went back and said, what are the principles that are important to understand, which starts to establish the context in which you're going to apply these cloud native patterns. And so we talked really about 4 principles. We talked about immutability. That's a very important principle. We talked about reconciliation loops. We talked about, I'm trying to remember, the last one was composition.
There was another R in there, wasn't there?
Reactive. Yes, thank you very
right.
much. We talked about reactive, so it was immutability, reconciliation loops, reactive, and then composition, which is something that we've done all along. But the reason that we put it on the list wasn't that composition is new. It's that because of these other principles, the fact that you're programming reactively as opposed to request response, the fact that you are now writing APIs that allow you to declare what you want as opposed to saying step by step what exactly you're going to do, that has downstream consequences on the way that you actually put things together as composites.
Now that's a shift, isn't it, in the APIs?
Yes. Oh, that is a huge shift. It's one of my favorites, in fact. And it goes back to my it's a little bit more along the lines of functional programming. Because again, functional programming is really, when you get down to it, a statement of relationships. So when you make a recursive call, you're saying that actually my answer is, I'm going to program my answer as a relationship between the first part of my problem and the rest. And I'm going to trust that the answer comes back from the rest correctly. And now I only have to think about combining these two things. That's the way we do recursive and functional programming. And so, yes, this shift in APIs actually gets us much closer to that. It says, instead of an API being I'm going to tell you what to do step by step, my API is now, here's a declaration of what I want. And then the implementation, that the semantics around that declaration in the Kubernetes world come in the form of controllers.
Controllers, right. We'll get to that. So the evolution of APIs is very interesting, isn't it?
It is.
My roots as a tech journalist came with Sam Ramji helping me understand APIs, REST-based APIs, back in 06, 07 timeframe, or 08. But prior to that, we were, it was the era of web services, right?
That's right.
And even prior to that, it was like the client-server relationship. And before that, right, that was really those earlier days when we were going from mainframes up into PCs and so on.
Yep.
Where are we now then? I mean, if we're talking about the declared, we're hearing things too from, more machine-based infrastructure, right? Where the machines are talking to each other more, almost independent of HTTP.
Yep, that is right. And you just nailed it. It's that independence of HTTP, and it's actually even less, it's less HTTP, and it's more just our natural tendency to go to a request response protocol. So I have been doing this. I was there during the SOA days. I spent a lot of time doing a whole bunch of work in RESTful services. And even the shift from SOA-based web services, SOAP-based web services to REST was, there was a difference there. When we went to REST, we really started leveraging the HTTP protocol under the covers, request response, and those types of things, even if it was asynchronous. So asynchronous can still be request response. But what we were still doing in all of those APIs was, to a large extent, we were just putting a layer on top of an existing system. So I remember working with customers, and I was at EMC at the time, working with some of our product groups, where when we created that RESTful layer on top, what we were really just doing is creating a new projection out of a system, and that projection was still request response. So if we needed to change something in the API, we actually, because it really mirrored what was behind the scenes, we didn't achieve the autonomy that we hoped for from services. We actually were able to normalize on the protocol, use HTTP instead of some binary protocol that was specific to the back end. So we were able to we definitely got value from that, but we still had relatively tight coupling. Now what's happening is that we are moving towards a model, and this is where the principle that we talked about this morning of a reactive comes in, is that reactive doesn't necessarily mean that I'm being more loosely coupled, but what we want now is we want those APIs at the front end to actually be as loosely coupled from the back end as possible. And the way that we can do that is we can make the back ends actually just project out events. So there isn't a tight coupling there. They're just projecting out events. They're just saying, here's what's happening in my world. And now these APIs at the front end can just connect into that stream. And Mark talked about event streams, can connect into that stream and effectively create their own bounded context. This is the information that's valuable to me as a service. And I am not coupled. I'm not temporally coupled. So request response means that when the request comes in, I kind of need that back end to be there. If we're doing reactive, we can have a control loop, a controller at the back end that is constantly making sure that we take as quickly as we can, but usually in an eventually consistent manner, what's going on at the back end to what's now going on in the API.
That's fascinating. And these controllers, getting back to what I was going to ask about, have taken on new importance, for example, in the Kubernetes community.
Yes. One of the things I'd like to say is that Kubernetes got its fame from doing container orchestration.
Right.
That's what it's got its fame for. And that's what most people think of Kubernetes as.
Right.
But that is just a teeny tiny part of Kubernetes.
Right.
I actually believe that the most powerful thing in Kubernetes is that it is a system that it presents a new programming model. And that programming model is controllers. Those controllers are effectively infinite loops.
Right.
So what Kubernetes allows you to do is it's a platform that allows you to register infinite loops, and it keeps those infinite loops up and running. And so those infinite loops could be around container scheduling, and that's where they have some things out of the box. Replica sets, deployments,
right.
pods, those types of things. What that is there's infinite loops at the back end that are looking at this declarative API that says, hey, I want 5 instances of this app. Desired state. What do I have right now? 0 instances. I better spin up 5 instances. That's the replica set controller that's running behind the scenes. That's why if one of those goes down, it's this notion of you're never done. It's always in an infinite loop.
Replica set's there.
Yep. It
right.
says, okay, I see that you lost an instance. Your desired state is 5. You've got 4. Means I need to create a new one. Well, that's just container scheduling. But it actually turns out that you can apply that same control loop to a whole host of other things, like keeping DNS entries up to date,
right.
keeping routers up to date, paying attention to a build process where it says, oh, I've made a code change over here. That means you might have heard the term GitOps.
Of course.
So GitOps is effectively a controller. Mm-hmm. And Flux, which is brought to you by Weaveworks, mm-hmm. is implemented as a Kubernetes controller. It's constantly polling and watching the GitHub repository, or it's not actually only Git, but watching some type of a source of record and saying, I see here there's something new. That means you've defined in the controller what happens when something has changed. And things are always changing.
And that then brings me to what Joe Beda said to us earlier today in a conversation with James Water about Kubernetes being a platform of platforms.
That's right.
And that platform of platforms allows you to then to have custom resource definitions.
That's right.
And that allows you then to establish what Olga Kundish talked about earlier today with Spinnaker, and how Spinnaker can work as a stateful continuous delivery platform on Kubernetes. It all kind of fits in, and then yes, containers are there, but the containers are just what really essentially moves things around and makes sure things are in the right place.
That's right.
And then it's a matter of like, well, am I efficient with my containers, right? But then that's another conversation that then seems to then emerge, and perhaps we can end our conversation here, is like this issue of efficiency, because what we saw with containers when they were used was like, what do I put in a container? And people were putting almost everything they could think of in a container,
yep.
right? And then there's been like more of an education about containers and how they're used. And it seems, from what I was hearing from Joe, that's kind of this space we're now with custom resource definitions, right?
Yep.
And this is where I'm interested about Pivotal and its philosophies, because Pivotal's always taken much more of an opinionated philosophy. And so how is that opinionated philosophy emerging then with how you think about Kubernetes as a platform, as custom resource definitions and so on?
Yep. I love that. Wonderful question. So I've been with Pivotal since the Pivotal spinoff. I came from EMC, where I worked in the corporate CTO office doing architecture and emerging tech. I still essentially do that, but very customer engaged, which is why I've been working with Kubernetes the last few years. And for the last the whole time I've been at Pivotal, as I've engaged customers, I have said, we are unapologetically opinionated. That's what we do with our Cloud Foundry platform, is we bring you those opinions, and it's those opinions that are going to make you that much more efficient. And that hypothesis, that theory that we had 6 years ago has proven to be extremely valuable. Now, that said, those highly opinionated, those opinions that we brought, really constrained the space of problems that we were solving. It constrained the space to things that were more cloud native, cloud friendly. You didn't have to be all the way to every single cloud native pattern, but you had to have a certain set of them. And that was where those types of applications worked extremely well. Now, a lot of those things that we've done in the platform are valuable even for other workloads, the workloads that are not as cloud native. And that's where Kubernetes has shown. Now, for clarity, I may have said this earlier, but Kubernetes, its initial set of use cases were the same as what we did with PaaS. And the replica set is a very opinionated controller that's in there because it assumes statelessness. It assumes that when it's checking its health endpoint and it doesn't get back a response, that it's totally fine to kill that container and create a new one. So that is something that we assume as a part of it. There's some opinionation built into that. Because Kubernetes is a platform for building platforms, it allows us now to build to a broader set. It allows us to solve problems that have different opinions, and that's what the custom resource definitions give us the opportunity to do. And those controllers, so the custom resource definitions coupled with these controllers, these infinite loops, allow us to say, okay, well, there's a different category of use cases that brings a different set of opinions. And here's a mechanism in Kubernetes to be able to satisfy those. Now, back to your question of how does Pivotal feel about that? Again, I used to say we're unapologetically opinionated. Now what we want to do is we want to expand to address some of those things. And in fact, Spinnaker is a great example. Build service is a great example. Ingress and routing, these are all components that we ourselves are no longer building the way that we used to. We are building them as custom resource definitions with controllers. So we ourselves are embracing Kubernetes as a platform for building platforms.
Secrets seems to come into that.
Absolutely, yes. Secrets, I mean, literally almost everything that we have in the PaaS platform can be rethought. We had a couple of control loops built into the platform. Bosch in the infrastructure layer, Diego in the container orchestration. But we didn't embrace this controller pattern throughout the architecture. We built it quite a number of years ago. So now we are starting to take some of those capabilities and say, hey, this controller pattern and this CRD pattern is so foundational. That wasn't foundational 6 years ago. But now with the advent of Kubernetes, that's so foundational that we can actually do so much more with that as a base rather than raw compute storage and network, which is what we built Cloud Foundry on 6 or 7 years ago.
Well, it almost seems space age going back to your aeronautics days. But thank you so much, Cornelia, for taking some time to talk with us. It's been a fascinating conversation.
Thank you, Alex. It's been a pleasure.
Pivotal offers the platform tools and methodology to help you deliver exceptional user experiences. Pivotal Platform helps you ship and run all types of apps in a secure and highly available way anywhere you want. Pivotal partners with you to change how you build software. Learn more about Pivotal at pivotal.io. Listen to more episodes of the New Stack Makers at thenewstack.io/podcast or subscribe to us on your favorite podcast network. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.